Hey everybody, happy Tuesday. Good morning, hope you're doing alright. So we had a travesty here. I ran out of coffee, which is like the saddest thing that's ever happened. So I switched over to Coke this morning because there's no coffee. It's so weird and so sad. This stuff is like super bubbly too. It's weird. Not used to drinking Coke. I guess I'll drink Coke Zero, but not usually the regular Coke. But it's what we had, so we'll make do. All right, we got a couple things today. We're going to talk about the lab here for classes, and then we'll look at inheritance. I don't know. I thought I had enough for another pot, and then I didn't have enough for another pot, and I'm sad. So we'll make do. We'll make do. So I'll pick some coffee up today. Make sure I restock. I used to have like a ton of it. Okay, so all right, I'm a little bit lying. I do have coffee, but it's this flavored coffee that someone got me for Christmas, and I'm not a fan of flavored coffee generally, and just did not want to make that stuff. So if I really needed it, I'd have it there, but I think I'd rather have the Coke than this weird flavored coffee stuff. But that's just my preference. All right, so we're going to talk about this animal class here and see what we can get. Net beans. Now, we're not going to do a ton with interfaces. That's a topic you'll pick up more later on in data structures, but we do want to introduce the idea and look at some of them, kind of have a general understanding of interfaces and how they work, and then we can go from there, okay? Let's see. Maybe it'll start. I don't know why NetBeans is being so grumpy. That one. I am looking at different tools. The problem is I can't get them installed on the virtual desktop for you folks. So I don't want to show something that's not available to anybody who's using that option, but I found one that worked pretty well for us moving forward, which I'm pretty excited about. So we'll see. Maybe we do have some hope. Beans does a lot of good stuff, but it's just a little slow. I know. I gotta get that laptop. I just gotta order one. Yeah, my encoding is overloaded. Yeah, go figure. Hang on. Did my settings get changed again? I had these settings in OBS, and I feel like they got changed. And then I fixed it, and I wonder if I got changed again. No, it's using the hardware encoding. All right, so just my computer sucks. That's all. It's I think it's just asking it to do too much apparently this morning. Yeah, I'm at 100% CPU. There we go. That's good. Let's see. Close out of that one. What else? I don't think these other ones take a lot of resources. Yeah, NetBeans, Edge. I hate this window manager. This is the problem. I think that's the problem there. But we're getting there. All right, now we got a little bit of room. All right, we'll start up a new project. We'll do Lab 3. It's a decent spec laptop still, too. That's the sad part. lab 3. Let's put this one in our 2151, enter 2022 folder. How'd lab 3 go for you folks? I didn't get a whole lot of questions from anybody, so generally I assume that's good news. If that's a bad assumption, then let me know that no questions are. Maybe that's a bad thing. I'm not sure. So we didn't need anything here in main, right? The only thing we needed here was a class for animal. So if you had stuff in main, go for it. Great. You know, you probably wanted to test out your animal class and make sure it works, but nothing necessarily here in main. Didn't have to have anything in here. We're just going to go add a new class to our package. We'll go new Java class, call this one animal. All right, good to hear, David. Thanks. And we've got animal. So a couple notes about animal here then, right? Maybe we'll put this on a block for now, and then we can start trimming it out as we go. So it's going to have private attributes for name, color, weight in kilograms, noise, food waste factor, which is a percentage. So that's probably a double. So we'll have a private string for name. We'll have a private string for color. We'll have a private double for weight in kilograms. And again, anytime you're using something that has a unit, you should definitely include it here. Mikey, nice job. Got it done in a reasonable amount of time. That's not waiting till the last minute, I take it. And then a double for waste factor. All right, cool. So we have our private attributes. Yeah, nothing really in the main part, and that's fine. No big deal. All right, get attributes for all of our attributes. That's pretty straightforward, right? We're going to let NetBeans do that work for us here. We're going to right-click and say Insert Code, Getters, and just check everything. Check the box. Now we have get methods for everything. Get name, get color, get kilograms, get weight in kilograms, get noise, and get waste factor. Awesome. A constructor that accepts arguments for all the attributes. Again, let the tool do the work for you. Insert code, go to constructor, check all the boxes. Boop, 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 boop. Yeah, I ran out of time. Yeah, sometimes that happens. If you guys have it partially done, please turn in whatever you have partially done. I'm definitely going to be very generous for partial points here on labs. It's mostly participation points for these. All right, so we got our constructor here, and then we need to add a method for eat that accepts an argument for the food, weight of the food in kilograms, increases animal's weight by the food factor, and then a set food waste factor. Let's do the set waste food factor first, maybe. So how about public? Now, we don't really have a great way, because one of the things this is supposed to do is ensure that it's a valid percentage between 0 and 1. That should be like a little lower here. Yep. So ensure it's a valid percentage. So probably our best bet here is going to just be returning a Boolean value of true or false. We'll talk about the right way to do this later. But for now, I think a Boolean is probably the easiest way to communicate back that this was not valid or it was valid. This will be set food waste factor, given a double for the waste factor. Doesn't have to be perfect, it just needs to be done. That's a good mantra. That's a good mantra. I heard somebody gave some advice that sounded really awful at first, but if you thought about it, it was actually pretty good. And they said, anything worth doing is worth doing poorly. Because you're at least trying. You're at least going to give it a start, give it a try, and make a little bit of progress on it. And that's okay, right? You know, we got to get up, we got to get out of bed, we got to at least try for the day. And if you get a shower in, good for you. That's great, right? You know, we can at least attempt these things. All right, so here's our set food waste. So we need to check to see if it's between 0 and 1. So we're going to say if my waste factor is less than 0 or my waste factor is greater than 1. Right? This is between, and you know what, probably less than or equal to's here. So I'm going to define either of those things would be invalid. I'm going to return false. As we're going to say, this is no good, I don't want it. Yeah, perfectionism is terrible, for sure. There's another good saying is don't let perfect be the enemy of good. I think is very common, especially when it comes to software as well. Like there's a lot of things you can do to make something perfect, but most of the time, if you get it to good, that's good enough, right? You don't have to fix every last little thing or add every little feature. You want something that accomplishes your tasks, yes. So we're not saying good doesn't accomplish the tasks, but it gets it done. But maybe you're not entirely happy with the layout or the design, or you thought you could have changed something. But if it accomplishes the tasks, that's good enough. Right. So if the waste factor was no good, we would just return false and we don't change it. Otherwise, we set the waste factor to the waste factor, and we can return true. Now, we probably should set it to something here, though. Right? If it was invalid, I probably want to set it to some default, right? To tell them, hey, they gave me a bad value, that sort of thing. And this one's a little bit tricky because we don't necessarily know what a good default is going to be here. So either you did or you didn't. That's okay. If you had one or not, it's no big deal. Right? And then we're going to have our add method for eat. So public. This one didn't say it needed to return anything, so we'll just call that one a void method. Eat a double for food in kilograms. So we're going to increase their weight by the waste factor. So again, this was a little bit vague on what that really meant, but my thought was if your waste factor was like 95%, then you would gain 5% of the kilograms, right? And does that kind of like subtract out their waste factor? So we're going to take the weight in kilograms, and we're going to increase it by the food in kilograms times the waste factor. So if the waste factor was 95%, we're not gaining 95% of that. We're really gaining 1 minus that, the waste factor. Right? And again, if you didn't get that math that exactly the same way, that's okay, because I'm not going to be particular here. But whatever that, 1 minus the waste factor, right, multiplied by that food, added to their weight. As long as we're increasing their weight here. That was kind of the goal with this one here. Right? And that should be our animal class. Right? If you want to add some default, great. Maybe we default it to 95%. Why not? Or 99%. Who knows? Right? We'll say you only gain 1% of all the food that you eat. Man, I wish that were true. I think it depends, right? This has other factors. This is not, it's okay. It's not perfect. Okay? So if we wanted to, we could then go make some animals over here. Wasn't required. Yeah, you could return a double for each, sure. Their new weight or the weight that they gained? Yeah, definitely. Yeah, so if we wanted to do that as a double, get this is the double for the gain, equals that, add it to their weight, and then return the gain. I like that. Yeah, either way is perfectly fine. Yeah, this was not very, it wasn't very explicit on what you needed to return here. So any of those would be perfectly fine. Excuse me. All right, so let's turn in lab 3 to GitHub here. Turn in is the wrong word. We're going to commit and sync our repository here, 2151. I finally did a little bit of cleaning up with some of those repositories, but I've got too many of them hanging around. All right, well, I don't need any of this test stuff. I don't remember what I was doing with test. So if you uncheck the boxes, it won't commit any of that stuff, which is fun. So sure, we'll commit this. This is lab 3. I'll commit. Yeah, test was empty anyway, so yeah, sure, we can get rid of all that. I think I was testing out someone was having an issue. I want to try it. All right, we can just get rid of those. So discard will revert any changes, so a new file just gets deleted. So you gotta be a little bit careful if you want to go discard changes, but I think you should be in good shape otherwise. All right, so we got that out in the repository, and then we're going to take a look at interfaces here. Now, did you want these named by chapter or by topic? I'm trying to remember. So this was chapter 9. I can call it chapter 9. Like interfaces. How about that? I think that's what we were doing. Both? Is both okay? Okay, I hope it's okay. I think I've got a little bit of lag again. I think a couple seconds ahead of you guys. So the idea with an interface, it's another object-oriented approach to sort of setting the rules or building what we'll call like a contract that classes need to follow. So if I make an interface, now you don't have to go right through the interface. You can do it through a regular Java class too, but this is more of the typing for you. We're going to say, here's a set of methods that are going to exist for anyone who says that they are going to implement my interface, and implement's the technical term for it here. So we're going to build an interface, and it says, okay, I will have these methods. What's cool about that is that you can use the generic interface type when you deal with these classes and not need to know the specific class that does implement them. That's not going to seem very interesting at first, but it gives you a lot of flexibility around actually separating out how I've designed things and then how I've implemented them. So it's one of these ideas that if we deal with abstraction, right, and we deal with things in this abstract manner, you know they have an application programming interface, their API. Here's a bunch of public methods that you can call, and they will do the things. We don't need to worry about how they do those things. So in our case here, let's see if we can write this interface. Let's say this one is, what am I going to call this one? Let's see, let's call this one drinkable. So the drinkable interface is defined as public interface drinkable. So then inside the interface, all we're going to do is we're going to list out classes.
So I made my eggs scrambled, so I'm going
to. Okay, thanks. You can try again? Look at that.
I'm going to wait for Rona
I get
to help or something.
Breakfast delivered with some scrambled eggs. Thanks, Susie. All right. I'll have that later. So what we're going to define in here are methods that any class that wants to implement drinkable is going to have here. So we don't need the public declaration. I know it's kind of like Grubhub, because anything that's in the interface is by default going to be public. So we just say, hey, here's the return type and here's the method name. So if we're going to be drinkable here, let's say this is a boolean for drink. And then we want a int for milliliters to drink. That defines the interface. So any class that implements this interface will have a method named drink. We're going to say this implements drinkable. And then maybe we'll have, that's probably fine for now. And we'll come and make a new class then. Now you can add interfaces right here if you want, and it's going to go and do a little bit of that cool stuff for you here. So if I click on browse, it's not even going to find them here, that's fine. So we'll call this one, how about Coke? Then to implement your interface in the class definition, so public class Coke, we say implements. There we go. If you spell it right, it'll highlight. We'll say drinkable. And now it lights up right away. It says, hey, Coke is not abstract, does not override abstract method drink in drinkable. What that means is the method here is defined, but it's abstract. It needs a concrete implementation, or this entire class needs to be an abstract class. We'll talk more about that later as well. So say, okay, implement all of our methods. And we get a little nice override tag. a public Boolean drink, and then it throws an exception. We don't want that right now. So those you can change later, but we'll just delete all that out. Okay, so what does it mean for us to drink then? Right, for our Coke, right, we can go define all this sort of thing here. So we can have a private int for milliliters, liters. What do we have? Our current milliliters. And then we had a private int for max milliliters, and then we had a, I don't know, whatever we had here. Sure. And then we could have a constructor, public Coke. And why not just say, maybe this should have been a can of Coke. So this is 355 milliliters. So our max milliliters equals 355. And our current milliliters equals 355. Right, so here, let me rename this. So don't just rename, don't just retype it here. Right-click, go to refactor, rename. This is can of Coke. Why not? Now it'll rename the file and the class and your constructor for you. It's awesome. So then to drink, if you tell me how many milliliters to drink here, again, we're going to check and see if the milliliters to drink is less than or equal to the current milliliters. Then we'll take our current milliliters, minus equals the milliliters to drink. And then we can return true. Otherwise, we'll just return false. Right? We weren't able to drink because it was no good. Again, so you can do some other sanity checking, that sort of thing here. But now we've implemented this drinkable interface. Not the most interesting thing yet, but now we can have another class if we wanted. Let's have this for mug of coffee. And then our mug of coffee is going to implement that interface as well. We'll say implements the drinkable interface. And then our mug of coffee, again, so private, probably has some similar attributes here. Current milliliters, max milliliters. Sure. And then my mug of coffee. We might as well fill this up here, right? So, and we'll just make this up. So max we'll say is, I don't know, 500. As I generally have a pretty large coffee mug sitting around here. Right, and then drink is probably a similar thing here. Don't need to be all that fancy about these. So now both classes are going to have this drink method. Now we probably also want a integer for get current volume in milliliters. Like if you're going to drink something, we're going to say, hey, you can tell me how many milliliters you have. Milliliters. Right, so you can drink from it and then you can get the current volume. Now both my classes are upset because they don't actually implement the interface. It says, oh hey, they don't implement get current volume in milliliters. Sure, so we can go fix that. So this should be current volume, right? In milliliters. There we go. I like that. Oops, I should have refactor rename. So right click, refactor rename, current volume in milliliters. Okay, and then we'll add that abstract method for get current volume, and this can just return our current volume. This one's pretty straightforward. Return current volume in milliliters. Awesome. I'm going to copy this one over to a can of Coke. And then we need to rename this one too, the current milliliters. Refactor rename that one, current volume in milliliters. Okay. Now they both look pretty happy. So we got some methods. We can use them here. Now what we can actually go do is what we'll call polymorphism, right? We've talked about this with inheritance. You can treat a class as another class, right? We talked about that, right? I can treat them as their parent class, but I get the correct behavior. Right, did we get that far? Now I'm not remembering if we got that far or not. So what we can do is we can treat something as the parent class type. And with an interface, it's sort of like a parent class. But what's cool about interfaces is you can implement multiple interfaces. here, where with inheritance you can only inherit from one class. So I can make a list if I wanted here. So let's make an array list of type drinkable. Call this our beverages. Was a new array list. And then, yeah, we can add our import for array list. And then I can take beverages and I can add a new can of Coke. And I can take beverages and I can add a new mug of coffee. Because both of these look like and act like a drinkable interface because they implement the interface. They meet the bill. So when Java goes and looks at it, it says, oh, sure, are you a drinkable? Well, yeah, do you have those methods? You've got drink and get current volume? Fantastic. Right? And then we can add our own method here just for fun. We'll call this public void chug, given something that is a drinkable beverage. And I don't know, maybe we'll make some random numbers here. So we can say, how about an int random mLs milliliters to drink is math.random. And let's do times, I don't know, let's go times 50 plus 1. And we want to treat all of that, right, as an integer. What am I missing here? It's the wrong number of parentheses. Oh, goodness. Huh. Dot class expected, not a statement. Semicolon, return type, variable random is never read. That's a weird error there. Oh, my parentheses are on the wrong side of int. There we go. An int of one of these things here. There we go. That's why it looked so funny. Then I can take the beverage and I can drink. Then I ran the milliliters to drink. Right? And we can put this kind of in a loop. We can say while my beverage dot get current volume is greater than 0. Let's see if we can chug it. Now, this is going to be a little silly here because, you know, if we're doing this by random numbers, a lot of times it's going to fail and fail and fail. Maybe it's better to do it by one at a time. I don't know, but random might be fun. We'll see if it works. And then we'll say if we drink that amount, maybe we can print out drank, I don't know, plus random milliliters. Milliliters. Why not? So if we drank it, right, because this will return a true or false if it works, we'll say we did it. Oh, my curly braces, my goodness. Chug, 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 right? So then we can say for, we can do a little loop here. We can say drinkable beverage in beverages. We can call our own chug method given the beverage. Right? And anything that fits, anything that is a drinkable here, beverage, was it spelling it right? Static, there we go. Public static void. We can chug it. We can chug Coke, we can chug coffee, anything that will implement this interface we can go chug because we know it has these two methods, get current volume and drink. Now, it would kind of be fun too, right, if we like had, you know, of milliliters of the beverage.toString here. Be nice if we had one of those like toString methods. So let's go add that for us. So can of Coke, then we can add a toString. So we'll add override public string toString returns can of Coke. Right, and then our mug of coffee can return that too. So this, you know, obviously mug of coffee. Mug of coffee. Okay. So let's see if we can chug these. And what's fun here is even though we're treating it as the type of drinkable, right, as the interface type of drinkable, when these methods run, we're going to get the correct implemented version. Oh goodness, where do we have build failures? What? Okay. Build. Where's my errors? Just thinking hard about it. Set it built successfully. That's weird. Will it run? Violet. Oh, friends. It's gonna be one of those days. It's gonna be one of those days. It all built. Alright, no, I have errors. Where do I have errors? Contains files with errors. Pretty sure it just built, didn't it? Alright, clean and build. We'll see. Clean out all the stuff. Can we get a new fresh build? There's no errors. None of these have errors, do they? I'm confused, friends. Where's my errors? Yeah. The tasks? Is that where it's going to show me that? No, that's not what I want. Oh, there's no errors here, friends. Run the file. What is going on here? Format, and all formats nice. Drinkable, we got that. A mug of coffee. Why is it not showing me what it doesn't like? My goodness. Build. I think it likes it. Had no issues with it, right? Close out lab 3. Oh, I think, okay. I think the name of my package upset it here. So let me take out the dot here. Refactor. I think calling it interfaces, I think probably upset it. Nope. Okay, what's it upset with now? Contains files with errors. Where? What file do you have with an error? I'm so confused, friends. This is not supposed to work like this. Where's my action items? Is that what it is? There's no action items. There's no errors here. I want to like make it break and show me. Okay, see, now there's an error. Now there's an error. We put it back and the error goes away. Okay, built. Put it on get bonus points whoever finds the error. You know, at this point, I would give you bonus points. Yeah, for sure. Why can't it find... They weren't compiled with error, though. That's the problem. NetBeans, you're drunk. Go home. All right, it's my compile and save option, apparently. It ran this time. I don't know. But look, we chugged. We chugged. NetBeans had too many beans this morning. Yes, too many beans. So we chugged our Coke. We chugged our coffee. So even though we are treating these classes here as the type of drinkable, when you call the right method here, through the magic of polymorphism, it runs the correct overridden version. And that's the magic here. That's the beauty of it. That we can have classes and the correct behavior will run if we override the parent class. And that's the big fun thing here. Oh my goodness, yep. Whew, we got it there. So you can implement more than one interface. You can extend a class and implement an interface. Got lots of fun things you can do with it here, which is pretty cool. Let's see. Yeah, so technically you can have default methods. That's a new thing. I still get weirded out by them. So generally, when you have an interface, it is a purely abstract method. It says, here's the name of it, here's the return type, and then there's no implementation. Adding an implementation can give it a default here. And again, it's sort of weird. So I'm just going to avoid it here, but you might see it in later versions. It's kind of neat, though you can like modify an interface and not break everything downstream. Because typically, if you have an interface and classes use it, if you go change that interface, every class that uses it has to go and get changed as well. Right? When we added get current volume, we had to go change our can of Coke and our mug of coffee. Can you imagine if we ran a vending machine company and we had to change our interface? Again, doesn't seem all that interesting that we have this interface here, but what it lets you do is you can treat things as that interface type. We deal with them at the interface type so that I don't care how it's actually implemented later on. I don't care what kind of beverage it is. As long as it meets the description here, I can deal with it because I know it'll have those methods. Right? Anything else that you want to do, fantastic. You go for it. You can take care of it. So we can look at some other examples. The textbook has its set of examples, what it does for its products. So it'll have an interface that these products implement for their use and their examples. Again, my goal is to give you different examples so that way you can go see it my way, you can go see the book's way, you can do it with a lab exercise, and then you can use it in the project. So that way you get it a bunch of different times here to hopefully understand a little bit better with all the repetition here. Does that make sense? Now, another fun thing, and I don't think it shows it in here, there's a way you can check to see if a class implements an interface. Kind of like going the other direction here. So let me just Google that because Java class implements interface. This is a really cool thing you can do. A get interfaces method. Look at that. How cool is this? A class gets the class, and then it has a list of interfaces you can go through, and you can get the name out of the interface. Look how fun this is. So, again, maybe not the most interesting sort of thing here, but we can take a class here, so like our can of Coke. So this is our can of Coke. Coke equals a new can of Coke. And then I can get an array of class here. This is the interfaces equals coke.get. It wasn't class. Oh, I guess we have to do it off the class first. Sorry. Should follow these examples better. So we get it off the class first, then you can get the list of interfaces from that class. Which is weird, but that's okay. So coke.getClass. Then I can get the interfaces. Why are those tabbed in funny? It's driving me nuts. I'll just format it. Get interfaces, and then we can say for class in class. Oh, I guess we can't use the lowercase c class. How about interfaces? Ugh. Implemented interface. I need a different. Why classes? No, it's the type of class. And the interfaces. There we go. There's our loop. We can print out the implemented interface. Dot get name. There we go. Woo! My aspect ratio? I've got a very widescreen monitor at high resolution, so it needs to fit a little bit better into the regular view. So I think when I did the sizing of it, it got a little bit funky. Let's see if we can get out our interface names here. And I'm going to be a good person here and set an example of citing my source. Look at that, we see the drinkable interface. But anyway, let me go cite my source here. Look at that. And, you know, all that is actually nonsense up there. So I'm going to cut that. That's the actual URL. Okay, so we can see it implements then the drinkable interface. Check that out. How fun is that? And then we can say, you know, if the implemented interface, get name equals, what do we want, the drinkable, drinkable.class, here we go. I think we can compare it here. You can chug this. Here we go. So we should be able to compare those and see that we can chug it because the implement interface equals the drinkable class. But weird stuff in Java looking around here, but we found out you can chug it. So if you weren't sure if you could or not beforehand, you can go check to see if it implements an interface. Again, we're at the small scale, doesn't mean a whole lot. When we get to our next project, we'll do some more fun stuff with interfaces. Yep. Awesome. Hey, thanks so much for following along. All right, I think that's enough for now. You can go into the text to look at some examples. We can talk about our next lab exercise here, and then look at a couple upcoming due dates as well. So we have Lab 4, Inheritance Part 1, and Project 0. Oh, that's unfortunate. We got a lab and the project due. I'm sorry. I should try not to have double things here. But again, generally, hopefully you can finish these labs before we're done with class. So hopefully that's not too bad of a takeaway. So we're going to do another lab. We'll do lab 5 here. Well, I can't do the project because I need, like, every 2 weeks needs the project so we can get to doing the final project. And if these get delayed, then the final project gets delayed. And I can push the lab back if you guys want. What would that be then? Until, if it's not the 3rd, it would be, I forget that always pops up. It's the new notification trait irritates me. I just want, like, just the calendar. We can push that out, but then it would be due the same day as this lab. You want doubled labs? Is that fine? Can we do lab 5? Classroom. Let's see if we can load this up here. 2151. Load up lab 5. Let's see, 2151, winter 2022, lab 5. All right, cool. This is our Java template. Ooh, and I found out, I think next week we'll have a special guest join us, which is very exciting. So open the college Java template. I'm due for my review as part of being a new faculty member. So we'll have our dean, my dean, you probably don't even know his name, come and join us here, which I think should be fun. So I'm excited to show off how it works on Twitch land. Because I was a little nervous to tell him, like, oh, I'm not doing the Zoom thing like everyone else does, but we'll see how it goes. I trust you folks will all be kind, right? Try not to troll me too much. All right, so this is lab 5, so please submit the feedback, pull request, URL. Yes, I will definitely make sure I have coffee that day, for sure. This we do on the 8th. Is that right? Yeah, do the 8th. Okay, so we wouldn't be doubled up then, right? Because we'd be due No, we would be doubled up, so that lab would be due the 8th. Okay. Dates are hard, friends. Dates are hard. All right, lab 5. In our labs category, there we go. This is a lab. You turn it in text. Okay. There we go. So we're going to create some interfaces here, and we're going to use them. So nothing too crazy here. So we're going to have an interface for we're going to have drive for our interface. We're going to include methods for drive given the kilometers to drive, meters to drive, and probably again a Boolean right here. Dates like time are subjective, yeah. Boolean for drive, and then if we're going to drive, we probably, let's see, we need a Boolean, a double for, oh, that's lowercase d drive. Should follow good naming conventions here. Get kilometers per liter of gas. We'll just say kilometers per liter here. So your vehicles will have this kilometers per liter, how far they can travel, right? And then when you can drive the vehicle, let's see, what else do we need for drive? I think that's probably good here. And then we're going to create 2 classes that implement drive. Drive, similar to how we made classes for Coke and coffee. Okay, and then create a loop that drives the vehicles. They run out of gas. So probably also need then a double get liters in tank. This sort of thing. Maybe we'll call this drivable. If it's drivable, you can drive it. You can get the kilometers in the tank. You can get the liters in the tank. That sort of thing. I mean, anyone can make their own calendar, Mike. Yeah, the trick is getting other people to use it, I think, is the hard part here. Okay, so similar to what we did, make that drivable interface with these 3 methods, and then kind of like what we did with Coke and coffee, make a loop, drives the vehicles until they run out of gas. Okay, we'll just give it a little practice here, just a silly little interface and some classes here. So you can make any kind of vehicles that you want that implement the drivable interface. Oh, I gotta name this one better here. This is Lab 5 interfaces. Excuse me, there we go. Interfaces. All right, so Thursday then, we're going to talk about the solutions for the Inheritance Lab and Project Zero, and then we'll finish up Chapter 10, right? Should put us out to the last of our object-oriented skills. Yeah, lower object-oriented programming skills. There we go. A couple other miscellaneous things. It's not a very large chapter, so it should go pretty well, I think. Just some other cool things you do with Java. So packages, modules, documentation, enums. Yeah, that should work out pretty well. And then we'll talk about project number 1. That sound okay? If folks have any questions, thoughts, concerns? You doing all right so far? I got to get these other labs scored for you here, but in general, we've got pretty good participation. I think that's going pretty well. So yeah, feel free to reach out if you get stuck on anything. Again, with the project, Thursday, I've got time Wednesday afternoon for office hours. Hopefully it's mostly done by then, and you're not just starting. I know how things go sometimes, so we'll make do. So here's our interfaces. We'll commit and push that. So you got those examples out in the GitHub repository. Remember, that's linked out in content. You can find the GitHub repository out here. Ooh, poutine is good. I do like poutine. You can find the course repository here, and then all the recordings get archived out here. Okay. Did we not finish up Inheritance? I said part 1, but I think we finished it. All right, folks. If you want anything else, let me know. We got the rest of today to work on the lab, work on the project. Shoot me a message if you get stuck in anything. Happy to help you along on those. Okay. You folks have a good one, and I'm gonna go find some coffee. I think is the plan. So the Coke's just not doing it. It's not hot. I think that's what I'm missing here. It's a nice hot beverage. So, all right, folks, take care. Let me know what I can do to help.